Hello everyone. Can everyone see my screen? I'll try to move it as well. Yeah, should show. Okay. Hello everyone. My name is Ian Miguel Luge. I'm a student at UOG, University of Guam, and I major in computer science, and I'm an upcoming senior. So my project is about building a ZCTA, which is zip code level web dashboard for internet connectivity analysis in the islands of Hawaii. So just some short background. As we all know, internet is essential, and some may even consider it as a critical infrastructure, especially for school, work, healthcare, and our daily lives. Uh, it is an opportunity for me to present through this Zoom link through the internet because in 2023, it is reported that over 30,000 households in Hawaii, which is 6.3%, have no internet access at all. So I wanted to understand where these gaps exist across the islands and if the geography hinders these internet accessibility. This project aims to present the data in a way that's clear, interactive and human readable. Because when I was doing my research on it, it was more a lot of spreadsheets and just raw data. So I wanted to put it in a visual and visually appealing way so that other people can look at it. Okay, so here are the research questions that guided me throughout this project. First is, what is the current distribution of internet access across zip code tabulation areas in Hawaii? And then next is, through which connection types, fixed broadband, which includes cable, fiber, DSL, dial-up, satellite, mobile only, which is a cellular data, do household in Hawaii access the internet, again, broken down by the zip code tabulation area. Here are some of my data sources. So my main data source is the American Community Survey, which is from Census. It has 1 year and 5 year estimates, but this project, I was only able to use the 1 year estimates for now. Okay, I used 2017 to 2023, which is the range that was the data, which is the data is available right now. And the key fields that I used was B28002, which is a table about presence and types of household subscriptions. And I gathered the columns, like for example, total household and total household with internet connections. The access method that I used to gather the data was through the Census API, and I processed that data and collected it using Python with Panda scripts. The other data source that I was using was Tiger line shapefiles. This is broken down into zip code boundaries. And I used the year 2023, which also fits for the previous years. So I just grabbed the ZCTA GOID10, which is ZCTA5CE. That's just a zip code level shapefiles geometry. And then for this one, I accessed it differently. I downloaded the zip file manually from their website and then extracted the relevant data, which is the zip code shapefiles for Hawaii. So just more details about the ACS 528002 data from Census. It covers household level counts, again, for each internet access category. And then it is one record per Hawaii zip code. It also includes the estimate as well as the MOE for each access type. For the update cadence, it is released every September as a 1 year data and as a companion of 5 year series that can be used to smooth the sampling noise for smaller ZCTAs. When I was doing the project, I found that there's a lot of zip codes that have less households compared to others, and like there's a big gap in between them. So that's one way to help and aid that sampling noise. And then for the missingness and suppression, it is any cell based on less than 20 unweighted household, it's suppressed or it's left blank, so there's no data on it. And then also the MOEs widen again on those sparsely populated areas zip code. For the format of the data set, It shows the row household counts and the MOE as columns, and then it is delivered via the Census API as a CSV or JSON. I used CSV for this project. And then for the key strengths of this data set is that it is consistent throughout those 2017 2019 years. And it's also an official federal statistics, which is reliable and widely accepted by policymakers and researchers. Key limitations for this one is that there's no data on actual speed gears or devices owned, and there's a 10-month publication lag. So the 2024 data only arrives September 2025, which is we're not in yet, or we don't have it yet. And then the sampling error can be also obscure due to small ZCTAs. So again, just like what I mentioned, maybe use the 5-year series. Here's the data process that I followed throughout this project. So I created 3 scripts in total. First, I created a collect.py script. This one is just calling to the Census API, requesting for the data, and downloads the CSV per year containing only Hawaii ZCTAs, which is 967 and 968. And then the same script also grabs the 2023 Tiger Line shapefile, which is in zip, and then it stores it on that same directory, which is raw, data raw. And then I use another script to transform the data and merge them together, which is called clean.py. So each ACS CSV with the shapefile, they combine together using the geo ZCTA. And then here I also calculated the household level percentages, which is being displayed and being used by the dashboard. I also use a simplify geometry. So for the web maps to load faster, I'll explain why that's something that I wanted to try. And then it writes it into a one lightweight GeoJSON file. And then it also creates median access CSV file for the bar chart, which is used by the dashboard. And then lastly, I just loaded it in with the app.py. It's hosted by Streamlit, and it reads the GeoJSON, which you can pick and choose, and catches the data frame, and it fits it to Plotly for the corporate map and pie charts, as well as the bar charts. The app serves key percentages, again, an interactive map, a ZCTA level breakdown of the access types. This is all in the web app. Here's the key tools that I used. So I used again Python. I used requests, import requests, pandas, GeoPandas, Plotly.express, and Streamlit, again as the hosting. I also use a version control GitHub repo. And then for this one, I thought I would use more API. So I created that env file for that to just host or to just hold the API keys, but I ended up just only using one. So that's that. Here's just some sample codes. There's a lot more on this, but this one is just basically code that shows how to fetch from the API, and then it returns the Panda data frame. This is actually nice to see how easy it is in Python to do compared to JavaScript, because we did this before, or not JavaScript, for Java. We did this before with Java, and it was a little bit more complicated than this. And then the next one is just combining or creating the actual files, the CSV and the GeoJSON file from the 2 sources. Here's another sample code. This is just building the metrics. So just simple computation to get the percentages and get them from the column, and then assign them to another column in that new GeoJSON file. This is on the clean script, clean Python script. Here's some just short visuals, and then I'll present it as well later on. I'll share my screen just to explore the dashboard a little bit more. So I have a year selector and a variable selector, which is this one. And then the map is interactive. You can zoom, pan, and hover over it. And then there's a color legend and key metric on top, which is the main percentages that you would want to look at. If you scroll down, you can see the internet access breakdown. Again, for example, for this one, 96701 zip code, you can see how their internet access is broken down into. So mostly, a lot of people have multiple subscriptions to get their internet connection. And then last part of that dashboard is the bar chart, which compares rural versus urban zip codes on how they're getting their internet connections. Okay, so I'll just share uh, the dashboard really quickly. I don't know if you can see. Can everyone see it? Yes. Yep. Okay. Thank you. Okay, so here's the dashboard. Again, you can zoom in and see the corporate map. It shows you um, what what that means as well, what the color means. So, and then you can pick the years. For example, 2017 should give you the 2017 data on household connectivity. And then there's also different variables you can select. For example, wireless only users. This is for household that only uses wireless to get their connection. So that includes satellite and cellular data. And then other variables as well that you can look into, for example, low quality connections. And then if you scroll down, you can see per year, what is the breakdown, compare rural versus urban zip codes. For example, for this one, you can see broadband and cellular use. And then scroll down again, you can select a zip code and choose the year over here, and it should show you the breakdown of their connections. This don't always add up to 100 due to rounding issues, but they're pretty okay basis. But yeah, okay. Moving forward, okay. So just some key insights that I observed while I was creating this project. When I was looking at the data, rural broadband has caught up and slightly surpassed urban coverage as well. So that means there's a successful fiber cable build-outs outside Honolulu. And then another big thing that I saw was from 2017 to 2023, cellular data is now the dominant access mode statewide. So it seems like a lot of people are relying on those unlimited 4G and 5G plans. It was steadily increasing throughout the years from 2017 to 2023. And then another thing is dial-up has practically vanished, and a lot of households are replacing it with modern alternatives. And then wireless only household remains rare, especially on statewide, but it spikes higher in some of the zip codes, especially may be considered rural. But it did increase though from 2017 to 2019 again, maybe also because of that cellular data used and cellular data reliance. Just some future goals for this project. Before that is the limitations that I have for the data that I gathered. So for the urban rural rule of thumb, I just use the simple if the zip code starts with 968, then it's urban. Uh, I could replace it with a full census urban area shapefile, which is more accurate to identify which zip codes are actually urban or rural. And then the sampling noise as well, just like what I mentioned earlier, there's smaller zip codes that contains less households. Medians would help, but it's not shown in the dashboard yet. Then there's also the data lag. ACS releases these September the year after, so there's a 10 months lag on it. And then quality also not captured for all of this household internet connectivity. It only flags access and usage only, but it says nothing about speed, latency, or data cap. So we can talk about the quality of their internet connection. Future plans as well is just tackling those limitations, maybe overlay Ookla or MLab speed tiles, or whatever data is available to measure the real world performance in wireless heavy and wired heavy ZZTAs, just comparing does being wireless or being wired affect the performance that much, right? And then another good plan is just to tag ZCTAs by income and the ACP enrollment to talk about and look at affordability of the internet plans. And then just like what I mentioned earlier for the urban rural rule of thumb, just replacing the prefix rule of 968 with actual urban area polygons would be a good touch to it. Reflection, again, what I built is the end-to-end pipeline that takes in the ACS data, census data, and combines it with Tiger zip shape files, and then serve it as an interactive Streamlit dashboard that includes a core plant map. Skills gain, there's definitely a lot more than this in depth, but I learned in general working with GeoPandas data frame, Plotly, uh, designing, and Streamlit hosting, as well as handling the census data through the API. Throughout this project, I learned a lot of things, especially this is my first time handling or working with data like this, like data science projects. First thing that I learned is really breaking big problems into smaller steps, just like what I followed the collection, the cleaning, and then trying to present it. I followed those steps and then breaking those into even smaller steps really helped me in overcoming this project. Adaptability is also essential when working with real world data. Um, Looking for data is one big thing that really moved me towards this project. And then confidence through iteration as well. This again, just like what I mentioned, this was the first time working like this. So I just had a lot of trial and error and getting the right um, results that I wanted through iteration. And then I also had some lessons learned for designing usability, not just functionality. Again, I wanted to present the data in a more human readable format, which could help in for people in looking into these data about internet access. Also appreciating the real world context. I added it as last because I've never been to Hawaii, but when I was doing my research about this, I was like looking at the islands, just trying to think of why some places are not don't have that much internet access, and also like the big islands that don't have the shape files. I was wondering why some islands don't have zip code information on them, and then doing more further research, there's just some islands that don't have a lot of people or something like that. So it was really nice to uh, look at that as well. And then for my acknowledgement, thank you to all the mentors. Um, Thank you also for NSF for funding this program. And that's basically it. Thank you for listening.
Good job. Thank you. Are there any questions?
Are you planning to host this tool somewhere after later?
Oh yeah. So that's what I forgot to add on to as well. I tried hosting it, but it was the map that was giving me a problem. That's why I tried reducing the compression. But I'll try to host it as well because Streamlit has the Streamlit cloud hosting, and I'll look into it on how I can fix that problem.
Yeah, nice presentation. Thanks.